And now we're going to over to, last but not least, wonderful Bill Lilley, who is going to, obviously his role in Race for 2030 is really important. So it's great to have you, Bill, to sort of think about this concept of multi-objective trade-offs for net zero precincts to round out the discussion. So I will hand to you. Thank you.
I apologise that that's the front end of this and say this might be a little bit overly technical, a little bit low level, but I tried to think about, the range of stuff that we would do at sort of different levels of abstraction that we've talked to today, from relatively high level down to some of the complexity that we've talked to today and dealt with. Race, obviously, we're paying for this project. It's an important project to us. We are focused predominantly on the distribution system and its impact on emissions reduction and reduction of costs of energy provision for end users. But we do this within a broader whole of sector trade-off is what we're looking to achieve. But this is really just diagrammatically put down the sorts of things that we're interested in. This one is stolen from a talk I did on storage, so it's just got storage elements written down. Apologies, but I had a week of difficulties last week in being able to spend time with work. Really a proposition that I'd put forward here is that as we deal with these complexities, we need to have robust frameworks and indicators that allow us to do this sort of complex interplay between co-benefits and trade-offs across the system. And we need a sort of multifaceted approach with various analytical models that allow us to do that. And I'll talk today to different levels of abstraction in that. So the question I was posing was really, what is an appropriate framework, in terms of net zero precincts, and which indicators are best suited to look at this co-benefit and trade-off with the electricity market and green interactions and environmental benefits. What I probably should have written down here is a number of different co-benefits, whether they're environmental, social, technical, etc. But really taking and looking at that particular view. So in the material that we shared, I put down half a dozen different ways of doing this. There are more. So this is very much a non-exhaustive set of ways that you might try and solve this problem. And typically I would have worked with all of these at some point. And they're not mutually exclusive. So in often many cases, you would have been using 2 or 3 of these together when you're looking at a challenging sort of problem. And ultimately, what governs that is the type of decision maker that you're aiming at. So this could be, for instance, a DNSP, it could be a government policy maker, it could be a business. So depending on who those decision makers are, different levels of abstraction would be required. So that might include temporal resolution, spatial resolution that we talked to before, different versions of mathematical complexity, different amount of technical details, economic details, or environmental details that we might want to capture. So in a few slides, I'm just giving a high level view of different versions of this. I'm not, in talking to this, I'm not proposing that any of these is better than another, by the way. We're really just framing up the question of how should we look at this? What are the types of things that we think decision makers would need to know? So one of the things that I've spent time on before is looking at the adoption of multi-criteria analysis in order to look at a range of different scenarios and different outcomes that we might have wanted to achieve, but then to be able to put weights on those and allow different decision makers to ultimately dictate where those solutions go based on their preferences for different weighting functions. So this is just a paper, and this will be shared, so all the different articles are available here. Just gives a different set of weighting preferences over different criteria that are set to look at a range of different scenarios in this one paper. And here you're just looking at a very simple sort of min-max normalization that's used to do that process. But it's really just to say, at some point, you're trying to balance what are essentially a set of qualitative conditions, so people's preference for things, with quantitative approaches to try and be objective about saying, given those qualitative functions that you've got, how might this be represented mathematically so that it's objective and you're providing weights, that are ultimately based on the results of many, many different scenarios that you might be looking at. I don't know where my button went. This is where, an outcome with something like that might be, and you can see here for probably half a dozen or dozen different scenarios across those criteria, how those weighting functions might look. And depending on, what type of end user you are and what your genuine desires are for different parts of those functions, you would have different outcomes. So this is really just to be illustrative that can be quite complex. And being able to have that decision transparent and to be discussed, ultimately is what you want to do with these tools, is to help some discussion and make a choice, to be able to use tools to showcase that. I think the next one's probably going to show that in a broader graphical form. Now this one is complex, but I only really wanted to do this for one reason. And I think this is important to talk to the standard way that we do energy systems models. In the vast majority of cases, we do what we call essentially least cost solution sets. Now you'll use mathematical optimization to come up with a solution to a problem, given all sorts of constraints. And when you really dig into the solutions, and if you run lots and lots, potentially millions of scenarios, you'll get a distribution of those, and you'll find that there are very, very different futures that come at a cost that isn't that different, because you're discounting in the long run. So whenever you use present versions of cost, you'll ultimately look at things, and everything we do is really looking at long-term impacts in this space, looking at climate change, looking at large-scale change. By the time that you take those and you discount them back, you can actually get some very, very big differences in solutions, but not a very, very big difference in outcomes. And this particular chart is really just illustrating that type of concept in terms of the probability density function that's displayed on the chart here. Now that's at what I would have called a medium to high level. We can move down into a sort of moderate level of abstraction, and this is talking to the sort of stuff that we do now in the net zero precincts, of looking at different models of adoption. And here, this is just a mathematical approach for using a reinforced learning methodology in order to look at different actors that might be doing control of a precinct type of material and operating with different versions of an energy market operator and different energy vectors here. So talking natural gas and electricity in this particular option, and you're looking at different outcomes, so heating demand, power demand, cooling demand, etc. Simply just a model of just showing, you're going down a layer. What would that layer mean for different versions of decision makers? You can probably switch over to the next one, because this is the complexity. The important thing out of this is you end up with what people call a Pareto front. So ultimately, you've got a set of solutions, and every one of these is essentially by itself viable. So you need those qualitative factors in order to actually choose which of these you might want to select. So as a decision maker, if you've got a whole bunch of different outcomes, how might I choose one of these very complex sets of outcomes that would come from a mathematical model? Apologies, I can't see the chat at this one when you're presenting. And this is the next level layer down, and this is based on some work from Monash. This is looking at, I think we talked to before, distribution networks. This is an example of what is called an IEEE test case. So often when you're developing up models, you'll use a sort of standardized model to compare how you're doing, how you're developing up things, how you're framing. And in this case, it's looking at the top of this, if you just ignore the sort of sums, essentially it's just saying there are 4 cost functions that you're trying to put into one single objective, and that's a different way of trying to solve a problem. In this case, for fixed and dynamic pricing, and looking at the impacts of voltage. So what would happen if I were to put EVs into a system? What would happen if I put a community battery into a system? What would happen if I put distributed PV into a system? And these are the sort of technical challenges that often you want to be able to talk to. You want to be able to do things at a high level, but often you'll have to get down into the technical feasibility and even do trade-offs there. What approaches might you use to do this? And finally, this is another version of that, but this is just showing different versions of cost distribution. So one of these is an equal cost model. So you're looking at a distribution of the same type of different study, but the same type of IEEE grid. What happens if I have a cost sharing model so that I'm sharing the network cost over all users versus what would happen if I had a distribution, location, or marginal price? And what might that look like? And how do I balance that out for all users? And how do I treat equity in this? So in this particular model, they were trading off efficiencies in economics, for instance, against efficiencies in equity. And how might I look at that problem? And depending on who I am as a decision maker, how important do I weight those different outcomes? So I know that looks probably a little complicated, but I just wanted to talk to versions of those abstractions and what the grid required, and just open up that framing as a challenge question of, how do you think that should be solved? Because Peter was asking me, what would you look at as a challenge? These are the sorts of challenges at 3 o'clock in the morning when I'm not sleeping. I'm trying to think about how to solve and what different models what we use. So I'll stop sharing that one.
Thanks, Bill. As you say, a lot of numbers in there, but I guess what you're trying to, if I take the Peter Ashworth layman thing is here, so all of the different trade-offs that we're talking through with net zero precincts, what you're saying is if we feed them into some of these models, we can start to put some numbers around to really start to quantify how they might make a different outcome.
Precisely. And I think the question is, when you're looking at different scenarios or when you're looking at different conditions of different outcomes, so that might be, electric vehicle charging, could be versions of PV and its location. What levels of information do I require to help a decision maker? And I might be looking at something that's very large and broad. So if I think about the climate change talk that we had earlier from Mark, that would have a higher level of abstraction that I would look at and do trade-offs at than I would if I'm doing a precinct development and looking at the optimal location of different assets within that. So, but if I'm looking at that and taking that over the entire WA context or the entire, Australian context, then I would have a different layer again to what I want to do there. So it was really just a challenge about, where do you see that you need to do this? Do you want to get trapped into the lower level detail of the precinct itself, the higher level outcomes more broadly? So, and I also just wanted to do something that was a little bit more, a little bit lower level in abstraction than the other talks.
All right. Brad's got a question, so I'll go to Brad.
Thanks. This type of assessment is really good in terms of a theoretical approaches to it. Yeah. What I find in practice is that we're in a space where we're reacting a lot. And the timeframes that we have around decision making and the information and engagement by decision makers is not conducive to absorbing or utilizing a lot of this type of stuff. And there are so many factors that are just not considered within these models in the real world that mean that they don't really find a place in the assessment of options. Politics comes down to it a lot. Personal preferences come down to it a lot. And I'm just wondering about the thoughts of the group on that, because like I said, I see a lot of research that has these type of assessments, where are the best places to put things in a network? And it's like, well, they're going to go where people want to put them. Yeah. Regardless of what the grid model says is the best place to put your solar panels. It's like whichever houses can afford it are going to put solar panels on, or batteries or whatever it is. And engagement in a VPP is going to depend on what the value is that's offered to the customers. How do you trade off that formal assessment process, which I can see much more in the policy around climate change at that high level? Yeah. So what is our general direction that we take versus the specific policy actions that are taken on the ground, either at a regulatory level, technical level, or social level?
Yeah, Brad, and I think, Brad, I'm going to say, I'll just preface the front end saying I have no preference or desire across any of those. I'm just saying these are the different approaches that get put forward, and the challenge is exactly what you're talking to. Where do you draw the line on that and what is required? I would say I have worked in systems with much faster adoption rates than Australia. And I've actually used this where I've done very big exhaustive modeling and used tools like this to objectively weight different types of decision makers and at a much faster speed than Australia does. So if done well, you can do that. But it is not without its challenges for sure. And there are many, many other things that go into it. The reason for doing weighting functions is to pick up on things like the politics that you talked to. How you create a weighting function is not the question. It's really about, given a weighting function, what would be the outcome, and what are the things that you would want to do.
Thanks, Bill. Peter Newman.
Thanks, Bill. I was a bit scared by your your options because we're not funded to do those kind of detailed data-based modelling. We are, however, wanting to get a policy framework together that will enable us to have some contribution to the processes. So is it what we've got and feeding into is a series of case studies that are all in words and some data. The data's there to show what works, but it's mostly about what works and doesn't work and how do you change that. So it fits more into what Brad's saying, that the policy framework will need to be something that can very quickly be discussed rather than understood in terms of modelling.
Yeah, absolutely, Peter. And again, I'm not trying to say that you have to do these levels of details. What I'm saying, though, is once you move past that particular discussion or as part of that discussion, you will inevitably get into technical trade-offs. And when you're at a technical trade-off, how do you best and objectively characterize that as part of that discussion?
Thanks. Okay, we're going to have to keep moving very quickly. Yeah. Patrick, you've got a question because we do need to go to the breakout rooms, but I'll try and fit everyone quick.
Sure, yeah. Really quick question. Thanks so much for the presentation, Bill. I guess my question is, how do you, when you have these models and you have people interacting with them maybe on a very surface level, and you also have really deep levels of complexity, how do you open these models, I guess, for critique and peer review, and so people can check these assumptions? I know you've got some thoughts on this.
What a great question, Patrick. So I do have personal thoughts on it, but I think there are a lot of the research community that unashamedly push for this to be open source for that reason, and so that there are, and they're very, very complex, by the way. Even if you make them open, doesn't mean that it's easily understood, just means that they're transparent. And I would say something like the ISP is very, very transparent, but very, very complex. And the tool that they use is a commercial tool, and it's a little bit black box, but everything that goes in it is well known. Taming that complexity and then being able to come up, and this is the question, by the way, is that what framing is required to tame some of that complexity and to simplify an answer for a decision maker? So they don't need to know the nth degree of that. They need to know it's there. But how do you simplify that message for them?
Great. Last one, Michael, and then we're going to go to breakout room. Thanks.
Thank you. That was an awesome talk. Thank you very much. So we do similar modeling. We've got a similar modeling suite that will be open sourcing soon if you want to dig into it. I just wanted to say that there's maybe more of a comment, but it'd be interesting to hear what your thoughts are, Bill. There's two big things that have come out of our modeling is, one, we can use it as a way of probing social issues of the people that are at the end of those models. But also it's interesting in a way to bring forward or bring to light unintended consequences of particular policy implementations. And that's particularly interesting from my point of view. And it's not just within the electricity sector, but I think across a lot of different sectors.
Yeah, absolutely. I think that the two things that pop out of exhaustive modeling like that, one is the unintended consequences of cost that come with it. The second is a better understanding of the fact that you can really, and this I'll get back to the least cost one because it's something that I've just seen and explored and no one really gets into. You can have some very, very different futures, if not in terms of net present value, not that distinctly different outcomes depending on the inputs. And particularly as you see renewables and their costs drive down and those sorts of things. It's And that gives you a very big challenge from a policy perspective of what do I do in the future. If you don't understand that broader set of outcomes, you know, and you just take a model and you say, well, the least cost mathematical optimization gives me X. You lose that nuance, you lose the ability to discuss different ways and different policy objectives, and whether they're positive or negative as part of that consequence. And, you know, there's a richness in those sorts of approaches. And I didn't touch on all of them. I only just grabbed a few different approaches here that you could use. And that's part of the problem in itself. I mean, so many different ways of skinning a cat, as they would say.
Look, thank you for that. Well, and thank you for everyone for staying the distance. We're getting much smaller now, but we're going to go back to our groups for one last time.
I thought mine might scare Pete off.
No, yeah, that's it. They saw and left the room. Absolutely. No. But I love also, Michael, unintended consequence. A lot of the work we do with global technology assessment is all around exploring the unintended consequence. So I think now you're going to go to your breakout rooms for one last time. There might be a few rejigs, and then we'll come back and do final reflections, and then Josh will do a bit of a wrap up for us. So thank you.